The M1 Garand rifle clanged as its empty clip ejected from the chamber, the metallic ping echoing across the Normandy beachhead on June 7, 1944. German Oberingenieur Hans Krüger, captured during the previous day's fighting, winced at the sound he had come to know and fear. For 2 years, he had dismissed American small arms as crude, inferior weapons, mass-produced toys compared to the precision-engineered masterpieces of German gunsmithing. Krüger was one of Germany's most respected firearms engineers, a man who had helped design the revolutionary St. G44 assault rifle and supervised production at the prestigious Mauser Works. To his trained eye, American weapons seemed hopelessly primitive, simple stamped parts where Germans used precision machining, crude tolerances where German tradition demanded perfection, and mass production methods that sacrificed individual craftsmanship for quantity. What Krüger couldn't have known was that he was witnessing the final proof of industrial mathematics over artisanal excellence. By 1944, American factories had produced over 4 million M1 Garand rifles, along with millions of other small arms that would arm not just U.S. forces, but Allied armies across every theater of war. The primitive American approach had created the largest, most reliable arsenal in human history. The ping of that ejecting clip wasn't just the sound of spent ammunition, it was the sound of German engineering philosophy being systematically defeated by American industrial democracy, one perfectly standardized rifle at a time. If you want to discover more incredible stories of how American industrial genius changed the course of World War II, make sure to subscribe to our channel and hit that notification bell. Oberingenieur Hans Krüger stood in the Mauser factory in Oberndorf in March 1942, examining the latest batch of Kar 98K rifles with the pride of a craftsman whose family had been gunmakers for 4 generations. Each weapon represented months of careful work by skilled artisans who hand-fitted components with tolerances measured in thousandths of an inch. German firearms were engineering marvels that reflected centuries of metallurgical tradition and mechanical precision. The Mauser Kar 98K embodied everything German military engineers believed about superior weapons design. The bolt action was smooth as silk, machined from solid steel stock to tolerances that ensured perfect function under any conditions. The barrel was hammer-forged, using techniques that compressed the steel into densities impossible to achieve through mass production methods. Every component was individually fitted by craftsmen who took personal pride in mechanical perfection. German small arms production emphasized quality over quantity through manufacturing philosophy that treated each weapon as a precision instrument rather than disposable equipment. Master gunsmiths spent years learning their trade through apprenticeship systems that preserved centuries of accumulated knowledge about metallurgy, machining, and assembly techniques that mass production could never replicate. The captured American weapons that German forces had examined during the early war years confirmed Krüger's professional assessment of enemy inferiority. The M1903 Springfield rifle was competently made, but lacked the sophisticated engineering that characterized German firearms. American manufacturing seemed focused on adequate performance rather than mechanical excellence, suggesting industrial philosophy that prioritized convenience over craftsmanship. Intelligence reports about American small arms production indicated manufacturing methods that German engineers found difficult to comprehend. Stamped metal components replaced precision machining, simplified designs eliminated complex mechanisms, and quality control emphasized statistical sampling rather than individual inspection. American weapons were being built like automobiles rather than crafted like precision instruments. The contrast between German and American manufacturing philosophy extended beyond individual weapons to entire production systems. German factories operated with skilled workers who understood every aspect of firearms construction, while American plants seemed to employ semi-skilled labor following simplified procedures that required minimal training. This democratic approach to manufacturing contradicted everything German tradition taught about quality control. Dr. Wilhelm Steiner, Kruger's colleague in advanced weapons development, had examined captured American ammunition that revealed similar priorities favoring quantity over individual excellence. American cartridges were mass-produced with tolerances that German manufacturers would have considered unacceptable, yet they functioned reliably despite lacking the precision that German ammunition achieved through careful individual loading procedures. The St. G44 assault rifle project that Kruger was helping to develop represented the pinnacle of German firearms engineering innovation. The weapon incorporated advanced metallurgy, sophisticated manufacturing techniques, and revolutionary design concepts that demonstrated German technological superiority over any competing small arms development. German engineers were pioneering automatic rifle technology that would define future infantry weapons. Personal correspondence from German soldiers in various theaters confirmed that individual German weapons consistently outperformed American alternatives in direct comparisons. Superior accuracy, better reliability under extreme conditions, and longer service life reflected manufacturing quality that mass production methods seemed incapable of achieving. German confidence in engineering superiority remained unshaken despite increasing reports about American production quantities. As 1942 progressed and American industrial mobilization accelerated, German intelligence services reported small arms production figures that seemed impossible to achieve while maintaining acceptable quality standards. American factories were supposedly producing rifles in quantities that exceeded total German output, while simultaneously manufacturing ammunition, aircraft, tanks, and naval vessels. The numbers suggested either propaganda exaggeration or industrial capabilities beyond German comprehension. But Kruger remained confident that quality would ultimately prevail over quantity in warfare, where individual soldier performance depended on weapon reliability and accuracy that only precision engineering could provide. The Springfield Armory in Massachusetts hummed with mechanical precision that would have impressed even German engineers if they could have witnessed the revolutionary manufacturing techniques being applied to small arms production. What Hans Kruger dismissed as crude American methods were actually sophisticated applications of industrial engineering that achieved quality through systematic processes rather than individual craftsmanship. Colonel Paul Thompson, Springfield's commanding officer and a former automotive engineer, had transformed traditional gunmaking through mass production principles that emphasized interchangeable parts and statistical quality control. The M1 Garand rifle rolling off Springfield's assembly lines was engineered not just for individual performance, but for systematic reliability across millions of units produced by workers with varying skill levels. The secret of American small arms success lay in engineering philosophy that prioritized manufacturability over craftsmanship complexity. John Garand's rifle design incorporated tolerances that allowed for production variations while maintaining functional reliability. Parts were engineered to be forgiving rather than demanding, enabling consistent performance despite manufacturing conditions the German tradition would have considered inadequate. Quality control at Springfield operated through statistical sampling methods that ensured consistency across thousands of rifles rather than perfection in individual weapons. Test firing procedures verified performance standards using ammunition samples. Dimensional checking confirmed parts interchangeability through gauge systems, and systematic inspection prevented defective weapons from reaching soldiers while maintaining production rates that individual craftsmanship could never achieve. The raw materials supporting American small arms production revealed industrial advantages that German manufacturers couldn't access under wartime conditions. High-grade steel flowed continuously from American mills operating without material shortages, while specialized alloys were developed specifically for firearms applications. Chrome vanadium steel for barrels, tool steel for actions, and synthetic materials for stocks were available in quantities that enabled consistent quality without substitution compromises. Training programs at Springfield produced competent workers within weeks rather than the years required for traditional gunsmith apprenticeships. Standardized procedures broke complex assembly operations into simple tasks that semi-skilled workers could master quickly, while systematic supervision ensured consistent quality without requiring individual expertise. Democratic manufacturing was proving more efficient than elite craftsmanship for large-scale production. The assembly line techniques pioneered in American automotive manufacturing had been adapted for firearms production, with results that exceeded traditional methods in both quantity and consistency. Workers specialized in specific operations rather than complete weapon assembly, enabling expertise development in narrow technical areas while maintaining production flow that individual craftsmanship couldn't match. Subcontracting networks extended Springfield's effective capacity across the American industrial heartland. Winchester, Remington, and dozens of smaller manufacturers produced components to identical specifications, enabling final assembly from parts manufactured in facilities thousands of miles apart. This distributed production system created redundancy that protected against disruption while achieving total output that centralized manufacturing could never accomplish. Innovation in manufacturing equipment enabled precision that competed with traditional methods while achieving unprecedented production rates. Automatic machinery performed operations that previously required skilled handwork. Computerized systems maintained quality control through statistical measurement, and specialized tooling ensured dimensional accuracy across millions of components. American engineering was systematically solving problems that German tradition had addressed through individual skill. The economic efficiency of American small arms production challenged German assumptions about the relationship between quality and cost. Springfield was producing rifles that performed comparably to German weapons, while consuming fewer raw materials and requiring less skilled labor. Mass production was achieving resource efficiency that craft manufacturing couldn't match under any circumstances. Personnel management at Springfield reflected democratic values that enhanced rather than compromised production quality. Workers participated in suggestion programs that improved manufacturing methods. Safety procedures protected employee welfare while maintaining productivity, and wage systems rewarded performance rather than social status. American industrial democracy was proving more effective than authoritarian organization for systematic achievement. As 1943 progressed, Springfield's production statistics began revealing the mathematical implications of American manufacturing philosophy applied to small arms production that would fundamentally challenge German engineering assumptions about the relationship between individual excellence and systematic capability. By January 1944, the mathematics of American small arms production had reached levels that challenged German comprehension of industrial possibility. The M1 Garand rifle alone was being produced at rates exceeding 750,000 units annually across multiple manufacturing facilities, while simultaneously supporting Allied forces through Lend-Lease programs that armed British, Soviet, and other friendly forces with American weapons. The distributed production network had expanded beyond Springfield Armory to include Winchester Repeating Arms, Harrington and Richardson, and International Harvester, companies that had never manufactured military weapons but adapted their industrial capabilities to firearms production with startling efficiency. Agricultural equipment manufacturers were producing rifles, while sewing machine companies manufactured ammunition components with precision that exceeded traditional armament factories. Technical standardization enabled this industrial miracle through engineering specifications that allowed any qualified manufacturer to produce interchangeable components. Parts manufactured in Connecticut fit perfectly with actions produced in Massachusetts and barrels made in Illinois. American standardization had solved logistical problems that plagued German forces, where different manufacturers' products often required individual fitting and adjustment. The ammunition production supporting Americans' small arms revealed industrial capacity that dwarfed German capabilities across all manufacturing sectors. Lake City Army Ammunition Plant alone produced more small arms cartridges monthly than German factories achieved annually, while maintaining quality standards that exceeded European military specifications. American abundance was being applied to every aspect of infantry warfare with systematic efficiency. Quality control innovations, developed for mass production, had actually improved weapon reliability compared to traditional craftsmanship methods. Statistical sampling identified potential problems before they affected large production batches, while systematic testing procedures verified performance under conditions that individual inspection couldn't replicate. American democracy was achieving consistency that elite manufacturing had never accomplished. Personnel training programs had created a workforce capable of maintaining production quality despite rapid expansion and employee turnover caused by military conscription. Women workers were performing precision assembly operations with competence that contradicted German assumptions about technical capabilities, while immigrant workers brought skills from diverse backgrounds that enhanced rather than compromised manufacturing effectiveness. The economic implications of American small arms production challenged German understanding of resource allocation in total war. American factories were simultaneously producing weapons for domestic forces and allied nations, while maintaining civilian production that exceeded European peacetime standards. Democratic capitalism was proving more efficient than command economy organization for systematic resource mobilization. Innovation continued accelerating rather than declining under mass production pressures, contradicting German beliefs that quantity necessarily compromised quality improvement. Engineering teams were developing improved manufacturing techniques, enhanced materials, and design modifications that increased performance while reducing production costs. American industrial democracy encouraged innovation through competitive methods rather than suppressing creativity through bureaucratic control. Intelligence reports reaching German command confirmed that American small arms production was supporting global military operations across multiple theaters simultaneously. Pacific forces were receiving weapons manufactured in American facilities. European operations were supplied through the same production networks, and strategic reserves were being accumulated for future operations that assumed continued warfare at expanded scales. The psychological impact on German forces became apparent through battlefield reports that described enemy small arms performance exceeding expectations based on pre-war assessments. American weapons functioned reliably under combat conditions, maintained accuracy despite harsh environments, and provided infantry firepower that German tactics had not anticipated. Mass production was achieving battlefield effectiveness that traditional craftsmanship couldn't surpass. Logistical advantages of American standardization were becoming apparent through captured enemy supplies that revealed systematic approaches to spare parts, maintenance procedures, and replacement scheduling. American forces operated with confidence that equipment failures could be resolved quickly, while German soldiers faced increasing uncertainty about repair capabilities and replacement availability. As 1944 progressed, the cumulative effect of American small arms production was transforming infantry warfare from traditional concepts emphasizing individual weapon quality to systematic approaches prioritizing reliable supply and consistent performance across massive scales that German engineering philosophy had never contemplated. June 1944. Camp McCain, Mississippi. German prisoners of war, including captured engineer Hans Kruger, were assigned to work details that would expose them to American industrial reality in ways that battlefield experience had never revealed. What they discovered about enemy small arms production would shatter every assumption about democratic versus authoritarian approaches to technological achievement. The camp's orientation included tours of nearby manufacturing facilities where prisoners could observe American industrial methods firsthand. Kruger found himself in a Remington Arms facility that was producing M1 Garand components, using techniques that challenged his understanding of quality manufacturing. Workers who had never built firearms before the war were achieving precision that competed with German craft traditions through systematic methods rather than individual expertise. The production statistics were staggering in their implications for continued German resistance. American small arms production had exceeded 4 million rifles while simultaneously manufacturing machine guns, submachine guns, and specialized weapons in quantities that equipped not just American forces, but Allied armies across every theater. German industry was struggling to maintain production levels that represented statistical noise compared to American output. Quality demonstrations forced Kruger to acknowledge that American mass production had achieved reliability standards that exceeded German expectations for democratic manufacturing. Test firing procedures showed consistent accuracy across random samples. Durability testing revealed service life that matched or exceeded traditional weapons, and field performance reports indicated battlefield effectiveness that contradicted German assumptions about the limitations of simplified design and manufacturing. The workforce diversity amazed German prisoners raised on Nazi ideology about racial and social hierarchies. African American technicians operated complex machinery with competence that contradicted propaganda about minority capabilities, while women workers performed precision assembly operations that German tradition had reserved for male craftsmen. Democratic inclusion was enhancing rather than compromising technical achievement. Training programs revealed American approaches to skill development that emphasized systematic instruction over traditional apprenticeship methods. Workers acquired competence in specialized operations within weeks, while cross-training enabled flexibility that allowed rapid adaptation to changing production requirements. Democratic education was proving more efficient than elite instruction for large-scale technical achievement. Innovation continued throughout mass production, rather than being sacrificed for quantity targets, contradicting German beliefs about the incompatibility of creativity and systematic manufacturing. Engineering teams were developing improved production techniques, enhanced materials, and design modifications that increased performance while reducing costs. American industrial democracy encouraged innovation through competitive methods rather than suppressing creativity through bureaucratic control. The economic efficiency challenged German understanding of resource allocation in technological competition. American factories were achieving superior cost performance while maintaining higher wages and better working conditions than German facilities. Democratic capitalism was proving more efficient than authoritarian organization for systematic achievement that benefited both producers and consumers. Personal interactions with American workers revealed attitudes toward technology and production that differed fundamentally from German hierarchical traditions. Workers participated in suggestion programs that improved manufacturing methods, safety discussions that protected employee welfare, and quality initiatives that enhanced product performance. Democratic participation was creating engagement that exceeded compliance achieved through authority-based systems. Correspondents from home painted pictures of German industrial decline that contrasted devastatingly with American abundance witnessed daily. German factories were struggling with material shortages, skilled labor depletion, and bombing damage that reduced production capabilities, while American facilities operated with apparent immunity from resource constraints or external threats. The psychological transformation among German prisoners reflected growing comprehension that their defeat resulted from systematic disadvantages rather than individual failures. American industrial democracy had achieved technological capabilities that authoritarian organization couldn't match through ideological motivation or administrative control. The evidence was overwhelming and undeniable. As summer progressed and D-Day success became apparent, German prisoners began understanding that they were witnessing not just military victory, but demonstration of social and economic systems that created sustainable advantages in technological competition that would influence post-war global development for generations. August 15, 1945. Victory over Japan Day. As celebrations erupted across America, German prisoners preparing for repatriation reflected on industrial revelations that had fundamentally altered their understanding of democratic versus authoritarian approaches to technological achievement. The final statistics were overwhelming. American factories had produced over 4 million M1 Garand rifles alone, plus millions of other small arms that had armed Allied forces across every theater of global warfare. Hans Kruger sat in his repatriation processing center, writing final observations about American small arms production that would influence his post-war career in German industrial reconstruction. The numbers defied every assumption about the relationship between quality and quantity in advanced manufacturing. American democracy had achieved both technical excellence and massive scale through systematic methods that authoritarian organization had never contemplated. The human capital development witnessed in American factories provided lessons that would reshape German approaches to industrial education and workforce management. Democratic participation in production improvement had created engagement levels that exceeded compliance achieved through hierarchical control. Workers who were respected as individuals rather than managed as resources had contributed innovations that enhanced both productivity and quality. Technical analysis of American manufacturing methods revealed engineering philosophy that emphasized robust design over complex precision, enabling consistent performance across millions of units produced by diverse workforces. Systematic approaches to quality control had achieved reliability that exceeded traditional craftsmanship through statistical methods rather than individual expertise. Democratic manufacturing had proven more effective than elite production for large-scale achievement. Economic efficiency of American small arms production challenged German understanding of resource allocation in competitive technological development. Democratic capitalism had achieved superior cost performance while maintaining higher wages and better working conditions than authoritarian alternatives. Free market competition had encouraged innovation and efficiency improvements that central planning had never accomplished. The innovation that continued throughout mass production contradicted German beliefs about the incompatibility of creativity and systematic manufacturing. Engineering teams had developed improved techniques, enhanced materials, and design modifications that increased performance while reducing costs. Democratic industrial organization had encouraged innovation through competitive methods rather than suppressing creativity through bureaucratic control. International cooperation through Lend-Lease programs demonstrated American ability to support Allied technological development while maintaining domestic production superiority. British, Soviet, and other forces had received American weapons that enhanced their effectiveness without compromising American advantages. Democratic values had created sustainable alliances that authoritarian systems couldn't replicate through coercive methods. Post-war planning revealed American confidence in continued technological leadership through institutional advantages that would persist beyond military victory. Educational systems, research facilities, and industrial infrastructure were being prepared for peacetime competition that would extend democratic advantages into global markets. American success wasn't temporary mobilization, but systematic capability that would influence international development. The workforce diversity that had amazed German prisoners became a model for post-war reconstruction that emphasized inclusion over hierarchy in technological development. Women, minorities, and immigrant workers had demonstrated capabilities that contradicted authoritarian assumptions about social organization and technical achievement. Democratic participation had enhanced rather than compromised industrial effectiveness. Personal transformation among German prisoners reflected comprehensive reassessment of democratic versus authoritarian approaches to social organization and technological competition. American industrial democracy had achieved systematic advantages that ideology couldn't overcome through political control or cultural tradition. The evidence was compelling and would influence German development for generations. If this incredible story of how democratic values and industrial innovation triumphed over authoritarian tradition inspired you, make sure to subscribe to our channel for more amazing tales of how freedom and ingenuity changed the course of history. The primitive American guns had indeed proven their worth, not through individual excellence but through democratic industrial achievement that demonstrated the superiority of free societies in technological competition that would define the post-war world. 4 million rifles had spoken louder than any propaganda about the power of democratic manufacturing to outproduce and outperform authoritarian alternatives.